Hello AAF kids, I am at a county training today, or this morning, through lunch, so I'm not able to be here to teach you this lesson, which is a bummer because this is one of my favorite lessons to teach. You should have a warm-up, which is lab sheet 5-2, which is old information, but has you practice putting equations into y equals on your calculator. And moving some parabolas up, down, all around, and it asks you to plot the vertex or the lowest point for some, so I want you to practice using your calculator and your second trace max and min values to find those lowest points. I have on the next slide here, I have the first. Right, this is the first sheet, and this is my key. So I just want to demonstrate for you. Obviously, you could copy this directly if you want, but what I'm looking for is when they ask you to graph a parabola, please make sure you graph it and put the arrows on. Here, they have not asked you to label anything, but they're asking you to compare when you subtract 3 and subtract 6 after squaring, to when you put numbers in before squaring and what they look like, and hopefully you're looking at the parabola move up and down when you change the value after squaring, and move right and left when you change the value or you put a number, a constant, in with the x before squaring. Here again, number 4, it asks you to predict before you use the graph, but I also want to make sure you realize that you can put an equation in vertex form into your calculator just as well as you can standard form. And then here for number 5, notice they ask you to label the lowest point. Here's where I want you to practice. You should obviously see that it's 5, -2, 5, 2, but practice with your calculator finding the max and mins. So I'm going to leave the back for you to do, so you might want to pause the video and do the back, because you're going to have to turn this worksheet in before the end of the period to the sub. Make sure you put your name up here. Name. Alright, now the second part of the lesson is the modeling. So we've done a bunch of stuff with the graphs without quadratics and algebra, without the calculator. Then we did a little bit with the calculator, and now we're going to do modeling problems, and you want to use your calculator. So quadratic modeling, just like with linear modeling, first there's going to be a story, English. You need to define variables. Regardless of everything that's happening in the problem, you have to identify only 2 variables to deal with, independent and dependent, and then make sure you include units. Points, you need 3, remember. Hey, Mr. Gatz, can you get my, I forgot to get my writing board, tablet, can you get that for me? Thank you. The points you need when you were doing the linear unit, I don't actually call him Mr. Gatz at home, P.S. You need 3 points, or, notice these question marks, because sometimes, and if you remember from the beginning of this unit, when I had you use quadratic regression to create calculators, we talked about the fact that I can only give you 2 points as long as one of them is what? The vertex. And then you can use symmetry yourself to generate the 3rd point. So it is true, you do need 3 points. You do need 3 points, but if the problem only gives you 2 and one of them is the vertex, you create the 3rd one. Then you're going to create the model. Remember, we taught you at the beginning of this unit how to do that with matrices. You don't want to do that for these quadratic modeling problems. You want to use the regression on your calculator unless I specifically say otherwise, and in general that's for a math paper. Thanks, son.
You're welcome.
Whenever you're getting a regression model, most of the times the data and the values are ugly numbers. You want to use your calculator to get those values and use them in your calculations, but you do not want to write down those gross numbers. So you write down the rounded model with 1 or 2 places past the decimal. Right? You write down the rounded model, but, and this is part of an IB objective, how can you use your calculator to enhance the mathematics? Not just use it for calculations. Use your calculator to store the regression equation with all of its gross variables so that you can eliminate or reduce errors in using a rounded model. Then of course you're going to answer the questions, and don't forget, since we started with a story, words, you want to end the problem with words and the units. Graph and label, and remember, when you graph and label, your model is quadratic. So you're going to be graphing a full quadratic that opens up or a full quadratic that opens down, unless you're asked for the reasonable domain. And if you have a reasonable domain, maybe you graph a dashed part for the unreasonable domain and solid for a reasonable. Maybe for this parabola, the reasonable domain goes to there, and then that part is unreasonable. So, the problem that I have for you, the football problem, is we have a quarterback that is throwing a football. And for those of you that don't know what a football field looks like, there is a goal, right, an end line. This is where kicking the field goal at the very back of the end zone. This is the end zone. This is crossing into the end zone. And once you cross here, you have a touchdown, and then there's the 10-yard line, the 20, the 30, the 40, the 50. And then on a real football field, it goes 40, 30, 20, 10, 0, and the back of the end zone again where the goalposts are. Since though I'm going to be talking about a quarterback standing on one 20-yard line and throwing across midfield, my math can't handle the fact that this goes 40, 30, 20, 10, 0. I need to adjust these values, and there's a couple ways I could do it. I could make the 50-yard line 0, and this be negative 10, negative 20, negative 30, negative 40, negative 50. Or I could go from 0, 50, turn this into 60. Doesn't matter how you do it. I just chose to do it this way. That way my independent axis, which I label yard lines, don't have any repeating values. So there's the receiver catching the ball. Here's the quarterback that threw the ball. So as you can see from your paper, at the time the quarterback is throwing the ball is 2 meters above the ground. So I realize here that I've got, right, a vertical axis, and the units are meters. Then the other information I'm given is that at the maximum height, what's the V word then that goes with this? At the maximum height, the football was 14 meters above the ground at the 50-yard line. Right? So you're talking about the model starting here, right, at the 20-yard line, 2 meters above the ground, increasing to a maximum value at the 50-yard line, and then the receiver catching it. So the questions they're asking me is, where is the receiver when he catches the ball? Well, first I need to go back over here and write an equation to model this situation. And they're telling me to write a quadratic model. So the first thing I have to write is, what is independent, what is dependent. So hopefully you see that independent is the yard line, and dependent is the height of the ball in meters. Then, what is the info I have from the table? I'm sorry, from the problem. I have at the 20-yard line.
Science!
Shut up. Math. At the 20-yard line, the ball is 2 meters. At the 50-yard line, the ball is 14 meters. To make a quadratic model, I need a third point, don't I? What is the third point? This is where the properties of quadratics come in handy, right? Through the vertex is what? What did I always make you draw? That's the vertex. What is true? This is the line of what? Symmetry. So if you have the point 20, 2, how far is it to your symmetry line? How many steps does it take here? From 20 to 50 is 30. So how many steps does it take over here? You also want to go 30. Whoops. Oh, I forgot I had some crazy football throws. Here, let's watch it since it's here. Check this out. Look at the ball. Woo!
Oh, he makes the catch! He makes the catch! Look at this, ladies and gentlemen. The man on the hill! The man on the hill completes the reception! Woo!
Pretty good, right?
We need an interview! Brian, how does that feel? Where's the video? Sorry, my client. One question, Brian, one question. Wait, this is amazing.
Sorry. Anyhow, I forgot I had that on there. Do I have any more?
Send it. To the room.
No,
Yes, gotta land in the purple. So clear the goal line. Once it goes in the purple, you're in the next round, and we'll just keep backing up so we get a winner. Keep going.
Why does this have to?
Step.
Okay, sorry. Alright. All my ink has gone away. Okay, where were we? Whee! So we were at the point where I was trying to create my model. Where I had, again, Sorry for that. The independent and dependent. Yard line, meters, and the points I had were 20, 2, the vertex at 50, 14. Talked about the line as this is the vertex, and so the line of symmetry, since we were going 30 yards from one point on the left side of the parabola to the symmetry line, and then we were going 30 more yards across, and I would land at what? The other 20-yard line, the opponent's 20-yard line, but remember we had called that the what? 80-yard line. So I have the point 80, 2, and I got that using a symmetry point. So I now have 3 points that I can enter into my calculator. So remember, you turn your calculator on, you hit Stat, Edit, and into L1 I'm going to put 20, 50, and 80. Hopefully you can see that if you use the other 20-yard line, the calculator doesn't understand the opponent's 20-yard line versus your 20-yard line. So I have to have another value. And then remember, the first height was 2. The second height was 14. That was the maximum. And the last height was also 2. Now, of course, I know this is oversimplifying. You've got weather, you've got all kinds of other factors actually impacting the path of the ball, but we can't deal with that yet. We can only deal with 2 variables. Now, let me ask you a question. This parabola opens down, correct? Since the parabola opens down, what do you expect A to be? Positive or negative? Well, let's find out. So I hit Stat, arrow over to Calc, Quadratic Regression. I want to store the quadratic regression into Y1. Calculate. Notice my coefficient for A is negative and very small, meaning it's wider, right? Going from one 20-yard line to the opponent's 20-yard line, that's a pretty wide parabola. The linear coefficient is 1.333. We know the x-coordinate of the vertex is 50. And then the y-intercept is negative 19. That probably is outside the reasonable domain, right? So you hit y equals, turn the plot on, and then remember you start from a zoom stat or zoom statistics window, because that guarantees that all 3 of your points that you put in are there. And that's a pretty decent window, right? I see the vertex. I'm high enough that I see the vertex there, and there's my parabola. When I hit trace, notice that when you hit trace first, up here it says P1. That means you're just tracing the plots, 1, 2, 3, and then you can't go any further unless you go back. But if you hit the up arrow, now you're on the equation and you have an infinite amount of points, and that's the power of a model, right? Power of the model is that given 3 points, I can generate a model that predicts an infinite amount of points for that football, for the path of the football. So now that I have a model, and remember, I'm not going to write down all these nasty variables. I'm going to write negative 0.01, and I'm going to write 1.3, and I'm going to write negative 19.3. So my model for the path of the football. Negative 0.01 x squared. Is it minus or plus? Plus 1.3x minus 19.3. Right? I write down rounded numbers, but in my calculator I have all the decimals, because remember, I'm going to use this model to answer these questions. I'm going to rewrite my model at the top. The path of the football is modeled by negative 0.01 x squared Where is the receiver when he catches the ball? This is, I don't get this from my model, I got this, that's how I get the third point. The opposite 20-yard line, which we called the 80-yard line. Right? The equation that models this situation is right here. I don't know why I wrote it at the top when they wanted me to write it right here. How high? How high is a meter question, which is dependent. When is the ball when it passes over the opponent's 40-yard line? So that is a yard line, which is independent. But what is the opponent's 40? Right? The opponent's 40 was our what? Right? So, how do I answer that? If you're given an x, they want a y. Given an x, what is the y? This is how you get credit for showing me that you're, with a calculator, that you're plugging in for the independent value. And then I use my calculator. y1 of 60. So how high is the ball? 12 2/3. Let's look at the graph and hit trace. And remember, you have to arrow up to get on the equation. Trace 60. Right? Do you see here? Here's the ball after it passes the vertex. Now let's say that we had entered the 40, right? We entered instead. Why do I get the same height? Right? So even if I made a mistake and entered 40, I would at least get the right answer, but I would see that you'd entered 40 instead of 60, so you might miss a point there. Why is it that we get the same answer though? What is it? That's right, symmetry. Units. The next one asks what yard line. That is an independent value. Would an opponent be on if he intercepted the ball at a height? Meters is dependent. So this time they gave me a y and they want an x. Replace y, or f of x, with 3.1, and then give me I don't need to see algebra when you've got your calculator. I need to see the setup. I have to see that you put y into the appropriate place. But then let's just go to your calculator. I want to know when this parabola crosses 3.1. And just like I showed you yesterday, I'm going to go over here and make this line dark. And I expect the parabola to hit that line twice. Now, remember, they're asking what yard line would the opponent be on if he intercepted the ball. So remember, the quarterback is throwing from here, the ball's going up and on its way down. The receiver is over here. They're asking you what happens, would the opponent be on the yard line over here. So I don't want this intersection place right as the quarterback threw the ball. That would be like the lineman coming up and smacking it out of his hands. But here, this is the intersection place I want. So we're going to say second, trace, intersect. And remember, I taught you how to do that. Just make your cursor go over, just make your cursor go somewhere over near the intersection place and hit enter 3 times. Bam, bam, bam. So at a height of 3.1 meters, what yard line are you on? Now this says 78.6. Please don't write 78.6 in your final answer. Tell me the algebra answer is 78.6, but say, so the ball would be intercepted where? Right? Remember we had, this was the 50-yard line, then the 60, then the 70, then the 80, but remember that really was the 40, the 30, and the 20. So it would be about what? 78.6 would be about the 22. Then you can say here, ball would be intercepted at about the opponent's 22-yard line. Okay, that's all I need, is about, right? And that should make sense looking at your graph. Now the next question is, what if this receiver had missed the ball? Where? Where? So once again, that's asking for a yard line. Would the ball have landed? Looking at your graph, what are they actually asking for? Right? They're asking for where the ball hits the what? Right? The ground. So that is x-intercept. So I'm going to make my window, my y-min, go down further. So which x-intercept am I after? The left x-intercept or the right? Second trace intersect, or I'm sorry, second trace 0. Remember this time when you're using your cursor, because you're looking for an x-intercept, the calculator has to see the range values change sign. So I'm coming from the top, so I need a positive y value. I hit enter, cross the x-axis until you have a negative y value, hit enter, and then you can just hit enter again when it says yes. That's 82.4. So what should I write? What if the receiver had missed the ball? Where would the ball land? You need to write 0 is equal. The height is 0. If they missed it, the ball would have landed on the ground with a height of 0. You write the equation down. and then you can just give me the answer. And you say, I want the farthest x-intercept, and that was, I already forgot, 82 point something? Is that what it was? $82.4 is so about what, the 18-yard line? About the opponents, right? Right? Now turn this over, and I want you to graph and label. Graph and label appropriately. So, to graph this, make sure your axes have units. Put on the points that you were given. The model. Again, write down rounded values. Terrible, terrible. Hopefully you draw a better parabola. Oh, it's terrible. It's just devastating. See if I do it better in a pen. A little better. Now I know this is negative 19.3, but it's outside my reasonable domain. So again, I prefer if you dash the unreasonable part. But since I didn't dash to begin with, I'm going to just darken the reasonable part of this graph. If you decide, if you wanted to include this as reasonable, saying, well, maybe, you know, if the ball got knocked out of the quarterback's hand, it would come, you know, go from ground to ground, I would accept that. Now, do you tell me if you think you would get full credit from this graph? For this graph, you have the reasonable domain indicated. You've got units on your axes. You have the 3 points. What are you missing? Ah, yes. Your line of symmetry. What else are you missing? X-intercepts. Good. I didn't find this one, but I can. You can just type in your left bound 0. All right. it's outside the window. No, doesn't like it. Okay. You could just type it in, but I guess not. Annoying. You could do the quadratic formula faster than this, right? Negative there. I need a negative y value and then a positive y value and then again 17 points. Again, you could put the y-intercept on there, but since it's in the unreasonable part of the domain, you don't have to. I have symmetry points with the two x-intercepts, but I also had symmetry points with the two given points, right? And I, of course, have the vertex. So tonight, you're to try those word problems, right? It was 1 through 7 all, and then plus number 18. Answer the questions like I've taught you. Create the model using quadratic regression, and graph and label. Even if it doesn't ask you to, you should graph and label. This problem you need to turn into the sub before you leave, but if you need to refer back to it, you've got this video, of course. I will see you tomorrow.